Whenever we think of the code that runs our lives, we picture glowing pathways etched into silicon. We instinctively assume that programmable machines belong to the modern electronic age. If you trace the history of computing, the timeline usually begins with 20th century codebreakers like Alan Turing or the room-sized mainframes of the 1950s. But the historical record contains a massive 800-year-old contradiction. Over 8 centuries ago in Mesopotamia, Al-Jazari built fully programmable, automated humanoid robots. The logic required to write a sequence of instructions and have a machine execute them doesn't require electricity. It was first solved using physical mechanics. In 1206, Al-Jazari completed a massive text known as the Book of Knowledge of Ingenious Mechanical Devices. Looking at this page from his manuscript, we see a reproducible, step-by-step engineering manual. Unlike the theoretical philosophy of his contemporaries, these were precise blueprints intended for other builders to follow. This raises an incredible question. How does an engineer physically write and execute code centuries before we learn to harness electricity? To understand the origins of modern software, we have to decipher the hardware Al-Jazari used to run it. Before a machine can be programmed to make a decision, it must first be able to move in a controlled way. Al-Jazari achieved this by pioneering the application of the connecting rod and the crankshaft, which he designed to power automated water-raising pumps. As you can see in this animation, the system captures continuous circular motion from a spinning water wheel. By attaching a rod to the wheel, that rotation is translated into a linear pumping action, pushing a piston back and forth inside a cylinder. This mechanical translation from rotary to linear movement is the core physical process driving modern internal combustion engines today. Mastering this controlled mechanical force was the necessary first step. Once movement is predictable, you can begin to power complex logic. That logic took a massive leap forward with Al-Jazari's castle clock. Standing 11 feet tall and powered by water, this structure operated as a programmable analog computer. Looking at this historical drawing of the clock, we can see the scale of its outputs. It featured an intricate zodiac display, moving falcon automata, and a row of mechanical musicians, all triggered to perform at specific automated intervals. Because the length of daylight changes throughout the year, the operator physically reprogrammed the internal flow regulators every single day. This allowed the machine to adjust the timing of the mannequins to match the seasons. The castle clock shifted engineering from creating tools that perform a static, repetitive loop to designing systems that could process variable inputs. The absolute pinnacle of this programmable logic was a royal entertainment device. Looking at this historical painting, we can see his design for a floating boat carrying 4 robotic musicians. In this 3D model, we can see the drum driving those musicians. A central cylinder rotates, studded with small removable wooden pegs. As the drum spins, these pegs strike small levers attached to the musicians' instruments. The system operates on binary logic. If a peg is placed in a slot, it strikes the lever, a physical state of 1. An empty slot leaves the lever untouched, a state of 0. By manually moving the pegs to different slots on the surface of the drum, the operator forces the robot to play an entirely new musical rhythm. This peg and cam arrangement is literal, physical code. Al-Jazari proved that the logic of software was solved mechanically centuries before we ever used a circuit board. Modern industrial automation focuses on maximizing efficiency, scale, and the replacement of human labor. Al-Jazari operated within a different tradition. In his era, engineering focused on inspiring wonder, aesthetic beauty, and submitting to the natural rhythms of flowing water. Take a look at the details of his elephant clock. He synthesized cultural symbols from across the known world, from an Indian elephant to Chinese dragons and Arabian figures, to create a sense of universal majesty. Al-Jazari used advanced engineering as a philosophical tool to manifest beauty through predictable physical laws. Al-Jazari codified the mechanical components, crankshafts, programmable cams, and valves that became the building blocks of modern engines and pumps. Modern industry uses this physical translation of continuous motion into mechanical power. It is the same rhythm Al-Jazari mastered 800 years ago. Every modern programmable device speaks a mechanical grammar. That grammar was first written by a 12th century polymath who looked at flowing water and engineered the future.